First, let's get our paper and cut them into pieces like so. Settle them on a flat surface. Next, get your comb and comb your hair several times. Since my scalp was aching at this point, I just used my comb on my cat since it would still work that way. This will help build up static electricity due to friction, as the free electrons from your hair, or in this situation from my cat's hair, are transferred to the comb, making the comb negatively charged. And once you place it near the pieces of paper, the papers stick. So what happens here is that the positive charges of the paper gets attracted to the negative charges of the comb, creating a separation of charge in the paper. So when the paper touches the comb, some of the excess negative charge in the comb is transferred to the paper. So after a while, the papers fall because the charges in the paper as well as the electrically charged comb are returning to their usual neutral state due to the transfer of their electrons. So for this experiment to work, you should consider two things. First is that the comb should be made out of plastic, since plastic is not a good conductor of electricity. So once you charge up the comb by rubbing it in your hair or combing your hair, the electrons in your hair gets transferred to the comb and the charges is stored in there and are not able to go out. The second thing to consider is that your hair should be dry. This is because water is another element that would be introduced in your comb or on your comb if you try to conduct this experiment. And it would not work since the water would not allow the paper nor the comb to attract each other. Cut the paper into tiny pieces and place on a flat surface. Next is rub the tissue against the drinking straw rapidly. Then place the drinking straw near the tiny pieces of paper and observe how the papers stick to the straw. When you rub the tissue against the drinking straw, the electrons from the drinking straw is transferred to the tissue, leaving the drinking straw to be positively charged. So when you place it near the pieces of paper, the negative charges of the pieces of paper would be attracted to the positively charged drinking straw, hence would stick to it. So when the papers stick to the drinking straw, the negative charges of the paper is transferred to the positively charged drinking straw. And after a while, both reach a neutral state and the paper detaches from the drinking straw. First, cut the paper into tiny pieces and place on a flat surface. Next, get a balloon and pump it up with air. Now, rub an area rapidly on your hair, then place the rubbed area near the pieces of paper and observe how they stick to the balloon. What happens here is the same with the first experiment. Due to the buildup of static electricity, the balloon has excess electrons on the area where it was rubbed, which makes the attraction stronger when placed near the piece of paper.
Repeat the steps you did for experiment C. Now instead of placing the balloon near the papers, you get to place the balloon near a steady flowing water. Observe how the water is attracted to the area where you rubbed on the balloon.
Unlike the previous experiments, this experiment involves liquid. In solid materials, protons stay fixed, having only electrons moving around. In this case, however, not only is the water liquid, but it is also in motion. You can see that once you rub the inflated balloon on your hair, which would transfer the electrons from your hair to the inflated balloon, and immediately right after that, you place the inflated balloon next to the flowing water, and you'll see how the water tends to be attracted towards the shape of the balloon.